the stage.
Yeah, hello. Thank you very much. So it's called eigr. It's a misspelling of the Eigr mountain in Switzerland. So it made a nice name to be used for an open source project.
I played it safe by just spelling it since I didn't want to get it wrong. But thank you very much. eigr.io.
Yeah. So I share my screen. Yeah. So do you see my screen?
Yes, we do. Not in presentation mode yet. No. If you want to do that.
I couldn't test that in advance, so perhaps I can share my whole screen, share screen, and entire screen. Allow. Now? Yes?
Okay. Yes.
Can you see it?
You need to switch the tab, I think. Yep. Well.
So it should be a PowerPoint presentation.
Let's see if it's getting...
Perfect.
Yes. Okay.
Okay.
Yeah. We'll let you know if we cannot see your next slide because it glitched on me earlier.
I can test the next slide. This is the next one. It's okay?
It works fine.
Okay,
so
thank you very much.
Take it away. Yep.
So hello, thanks for having me here at the 20th ACM SIGPlan Erlang workshop 2021. I'm excited to talk about a project I and a few collaborators have been working on for the last couple of months. So for the agenda today, I will, in this talk, I will give an introduction why we started the eigr project, why we think serverless runtime is relevant these days, and what we are currently building on as an open source project. I will talk about some technical highlights we have, and I'll go into the current state and challenges we are working on, why we think the Erlang system and the Beam is a perfect match for this project. So first, what is eigr functions? We named it eigr functions. It could be another name, but it's actually one of these principles that we have on other serverless runtimes like Amazon Lambda or Azure Functions, and we aim to be a serverless runtime, and that allows to enable the development and building of general purpose applications. It is an open source project. We are based on another open source project that is inactive at the moment. It is the Cloud State protocol or project, and we implement at the moment mainly a so-called service proxy for it. As said, it is based on a protocol. This has some advantages. I will explain this. And we have so-called polyglot SDKs. So we can provide SDKs for the most relevant languages that exist today to implement business logic for this serverless runtime. So for the technical highlights, there are 3 or 4, as you will see, but the 3 from a technical point are we have a service proxy that manages state also. We have a cloud native deployment story that runs on Kubernetes. Then there is a protocol that is gRPC based. We have a spec and a TCK. And as said, the programming model is a polyglot. There are SDKs with support for the most major programming languages in use today. And it runs on the Beam, which is nice, I think. So, and I will come to the first highlight. This is a service proxy. So there is a simple pattern actually for a service proxy, that is message in and message out. So we can think of a service proxy as a component that gets messages. It delivers the messages to a handling function in our case, and then it spits out a message again. So in zoomed in, this service proxy or this service can be depicted as we have it now in our implementation. So there are two containers. These are Kubernetes, run on Kubernetes in a pod. On the left side, we have the possibility to access the proxy on HTTP, gRPC, and also pops up, publish subscriber infrastructure. And we do some we do state management and replication, and we are communicating with the functions over gRPC. So this is the protocol that is spoken between the service proxy itself and a function that is implemented here. It could be in Go or in Java or Python, and the most popular language would be JavaScript for sure. Yeah, so this is the overview of how it is laid out. Our project is implemented in Elixir, and we also have a Kubernetes operator that injects these service proxies as sidecars beside a user function, a function that is implemented in this environment. There is something special. It is also special about the Cloud State Protocol, and also in our project. So usually function as a service architectures are stateless. So if someone wants to have state in a stateless environment, it has to access a database, as an example. But here we have something called inversion of state. So we bring the state to the function. So this is an example. Here comes a request in. It gets state that is already there. I will explain how this works. It goes to this function here on the right. So there is a context where the state can be accessed. Then there is the original request as a message. The function that implements the business logic, as an example, then responds with a response. And it also gets out change state if the function has state changed. And a state management component will handle this state outside of the request or invocation of the function, and the client that requested gets a response. There are different state models to choose. So this is a compromise where the user or the implementation of a function has to choose a state model. So there are action model, event sourcing, CRDTs, and value entities. It's like CRUD. It's a common CRUD model. Next, there is a protocol to use. eigr functions implement the Cloud State Protocol. It abstracts state, and the state models are defined in proto files. These are protocol buffer files. It is quite commonly used in cloud and cloud native and projects, and it has some advantages. One is it is based on HTTP2 and has a streaming support, and the specification for the protocol itself can be defined in protocol buffer files. Last, we have here a TCK, a so-called TCK. It is a technology compatibility kit. It ensures the compatibility of implementations of SDKs and also the proxy. So it ensures that the protocol between the components is valid and correct. One of the advantages to be gRPC based is we can have support for multiple or all gRPC enabled languages that are out there. So if there is a gRPC compiler, we can have an SDK or support for this language. So even if the serverless runtime is written in Elixir and running on the Beam, we don't have to implement user or business logic in Elixir. We can implement it in JavaScript, Java, or Go as an example. And all the languages I listed here are possible. So this is very interesting. We have support with high coverage, 100% actually, for 3 languages at the moment, and the other languages are coming from the community, also from the CloudStack community originally. And yeah, that's a great advantage to have these other languages available, and everyone can choose his favorite language. So current state we have and challenges. We have a service proxy in Elixir implemented. Our first challenge was to implement gRPC reflection that was not available for Elixir. And now we have, since a few weeks, we have a discovery and action protocol implemented. Our next challenges will be to implement state models, to improve SDKs, and enhance the TCK. So one interesting property of this project is actually to have developers and contributors that can write in different languages. So you could imagine if you have someone who is proficient in Elixir or proficient in Java, if someone comes and knows a lot about Python, he can contribute to the project even if he can't write or contribute to the open source project because he can't write Elixir. So it's an interesting aspect of this project, I think. So with this, I come to the end. So I said we are an open source project. We are a welcoming community. We have this Discord channel that is quite active, and I invite everyone to check it out. And if someone wants to join or help us with our challenges, I'm happy to help, and we are happy to introduce our project to them. Thank you much.
Thank you very much, Marcel. Very interesting project, and very in a direction that is really popular today. There is a question from Fred. I can also invite him to the stage if he wants to participate in discussion.
Yeah, great question. So, yeah, I don't know if it came clear with my presentation, but one of the, I think, coolest function is we can have state in stateless usually in a stateless environment. So function as a service often is stateless. And yes, the service proxy has to handle the state for the function. So yeah, we use Erlang with his functionality to build a great distributed system. And yeah, it's correct. It is a state manager for the function. So do they do state management as well? So the user functions don't. They choose a model. So if you implement the user function, you choose if you want to have event sourcing or if you want to have CRDTs as a state model. So CRDTs are it's replicated. It's a model to replicate data conflict-free in a distributed system, and they are very attractive from certain point of view. And the user function has to choose it. So this is the compromise you have to. You don't implement your state model by yourself. You get it managed, and you after you have chosen which one you want to use.
Mm-hmm. Thank you very much for the presentation and the answer. So we are supposed to start pretty quickly, but we will take a short 5-minute break since we have the leeway for the next session. And we will resume in 5 minutes.